somebody wants to do his units are all I've only had one class and that's actually been the case.
Really?
Where one, you know, 6 months, all the other instructors are like, no.
Well, unfortunately, I haven't tested. There'll be material that I haven't tested, guys. So I have to ensure that you know those objectives. Oh no, that'll help. No.
He's not even that.
It's like it's a real math class.
I know.
You know what I mean? Yeah, because she'll ask a question, what do you know the answer? And then she'll start controlling fucking idiots. We just don't know how to do that. Teach us. Or just move on. We'll figure it out.
We're almost there.
Okay, guys. So today what we're going to do is we're going to finish up talking about the counting methods, and then we're going to start into algebra of combinations and permutations. And then on Wednesday, what we'll hopefully do is we'll finish up all the material for the third examination, going through binomial theorem. And then also, next Monday what we'll do is anything that we don't finish, we'll just do then. And then whatever time we have left over, we'll review for our examination. So it's looking like our next examination is pretty definitively going to be, I got it already, you're fine, sir. Thank you. And then, so our next exam is pretty firmly slated for the 9th. Okay, so.
You're pushing it 1 week ahead.
What?
You're pushing this 1 week ahead.
Not really. I mean, we're done with everything, and I'm giving you guys a date for review, so I don't know. I mean,
No, it was supposed to be on 16th.
Alright, so, I mean, I guess I could just make up some more stuff to put on the exam, if you want, and I could just go and talk to you about the schedule. Yeah, I know, there's always options, I mean, you know, we just go with what I think might be best. Alright, so any questions, guys, as to what's going on, or anything like that? Okay, so correct me if I'm wrong, but I think last time we got up to this question to where we had the jury of 8 men and 9 women. And I think we got up to the letter D, and I'm pretty sure we did C, but we didn't do D. Is that correct?
Yeah.
Okay. And letter E doesn't exist because it just went down. So you guys can scratch out that E. E just says women. So. Anyway.
Scratch that out.
Well, I'm scratching out the letter before that. So, yeah, I'm not sexist or anything like that. All right. So this is a good review problem from last time. So how many 7-person juries can be chosen that consist of 3 men and 4 women? So remember last time guys, I talked about combinations and permutations and the difference between combination and permutation. So let's get into that mindset first of all. So is this problem going to be reflexive of a combination or permutation?
Combination.
Which one?
Combination.
Okay. And guys, why is it a combination?
Because it does not matter whichever person you pick.
Yeah, they're not. In other words, it's not. What do we call it? Indistinguishable, right? One man is not indistinguishable from another man. It's not like we gave names to the people. Okay. So this is still a combination problem because we're still picking from indistinguishable objects. So for the 7-person juries, okay. So we have 3 men and we have 4 women. So the way I think about these problems is that there's a number of ways to select the men and a number of ways to select the women. So I guess the first thing we might ask is how many men do we have total to pick from? Or
8.
Yeah, we have 8 men. And of those 8 men for this problem, how many do we want?
3.
We want 3. So that would be 8 men choose 3. 8 combination 3, right guys? All right, for the women, okay, how many women do we start with?
9.
9. And how many of those women do we want?
4.
4. Good. Okay. And remember, guys, at this point, you can use your calculator to evaluate those 2. So does that make sense to everybody, first of all, how we're selecting these? Okay, there's 7 people, 3 men, from which we're selecting out of 8 possible, 9 women, we want 4 of those. So that's how we set up these combinations. Right? Now, the other question is, what do I do, and we're going to compute these, but what do I do with these 2 combinations once I compute them?
Multiply.
We multiply them actually, okay? Because remember, the multiplication rule says if there's m number of ways to do event A and n number of ways to do event B, the total number of ways to do events A and B is multiplication, Okay, does that make sense, guys? Addition is if you want one or the other, okay? But this one we want them and, so we multiply. Okay, so we're just going to go into our calculator. We're going to multiply some stuff out, okay? So correct me if I'm wrong, guys. I think I showed you guys how to do that in your calculator, but just in case you forgot, let me do it again, okay? So what you guys would do is you type in the first number, 8, and then we're going to go math, and then we're going over to prom, or PRB. We're going to go down to NCR, not NPR, hit enter, and then we're going to select 3, okay? So I got 56 for that one, okay? So does that make sense, guys? Remind you guys how to do that, okay? And in case you guys don't know how to work your calculator, make sure you come and ask me so I can help you guys out with that, okay? I want to make sure that you guys are okay being able to do this stuff. And then, was someone able to compute 9-4? And if they did, what did they get for 9 times?
126.
126, sir? Okay. So we have 56 times 126, and then that's just going to be our answer. So what's the product of those two?
7056.
7056. Okay. So that's the number of ways that if we have 8 men and 9 women, to select the 7 people juries of 3 men and 4 women. Okay. Now that's basically the number of different people that we could pick on the juries, okay? But we don't know which ones are which.
If you have 9 events left 5, you get the same answer as if you have 9 left.
Correct, because the binomial distribution is a symmetric distribution. Okay. So 9-4 and 9-5 are the same values. In fact, we'll prove that later when we start talking about the binomial theorem. Okay. So there's several of them that do the same thing. Okay. So that's why it does work out like that.
It's really funny.
Yeah. All right. Other questions, guys? Okay, so another problem, because we don't have enough problems, right? How many 3-person, thank you, man, I appreciate it. Okay, yeah, go ahead and grab that one. How many 3-person juries consist of at least 1 man? Okay, so this is different, guys, because now it doesn't say exactly, now it says at least. So, a way to think of at least might be to replace it with the phrase at minimum, okay? So let's think of at least 1 man, and there's a 3-person jury. Okay? What are the possible options there for at least 1 man? You could have what?
1 man, 2 women.
So you could have 1 man in the jury, right?
Mm-hmm.
And this is for at least, okay? What's another option?
Or 2 men, 1.
We could have 2 women in the jury, right?
Mm-hmm.
Or I'm sorry, 2 men. Could we have 3?
Yes.
Yeah. Could we have 4?
No.
No. How come we can't have 4 men in this jury?
Because it's limits to 3%.
Because it says how many 3-person juries. How can you put 4 men on a jury that only has 3 people in it? Okay? So that's because it says at least. Okay? So at least means, whenever you guys see at least, it means you start with the minimal number and you keep going up until you hit the maximum number. Okay? Like for instance, if I said, to be in this class, you have to have at least calculus 1, right? That means you could be in calc 2 or calc 3 or differential equations, but at minimum, you have to have that prerequisite, okay? So does that make sense, guys, as to what at least means? Start with the lowest number and go up until you hit the maximum number, okay? Now we actually have to figure these out, okay? So if I want a jury with 1 man, that means it has to have 1 man, and also 2 women on it at the same time to get 3 people out of it. So, how many men do we have to pick from?
8.
How many of those men do we want?
1.
So, of the 9 women, we want 2 to get to a 3-person jury. Does that make sense to everybody, guys? Okay. So, don't forget, you have to have men and you have to have women to make a 3-person jury. Okay? So, there's a default there. Okay? If I want 2 men, well, it's set up, right, guys? Because instead of 8-1, don't we just make it 8-2? And instead of 9-1, that would become instead of 9-2, that becomes 9-1, doesn't it, guys?
Mm-hmm.
And then finally, for 3 men, that would be 8-3, 9-0. Is that good, guys? Does that make sense to everybody how we set that up? Okay, and again, by default, you can't just have men. You have to have women as well.
On the last, why are you choosing 9-0? Because we already know there will be 3 men.
Right, and there still has to account for women. So there has to be like a placeholder for the women no matter what. Okay?
That equals
So
0, so
No, it doesn't equal 0, Don, okay? We'll see that it doesn't equal 0, okay? So yeah, this guy, and some people think that 9's 0, but there's only one way to choose 0 people. So it actually is 1, okay? So that's okay. All right, let's compute these and then we'll figure out what to do with it, okay? So you guys do 8-1 in your calculator, that's 8. 9-2 in your calculator, that should be 36, I believe.
Yes.
8-2 is going to be 28, I believe. 9-1 is 9. 8-3, we know that, that's 56. And 9-0 is 1. Okay, so now I do need some of you guys to verify those values and just don't take what I have for granted. Well, we know 8 and 36 is good. Hopefully 28 is good.
Yeah,
28 is good? Okay.
Hey, is that 56?
What's up?
Is that 56?
8-2? Oh yeah, this is a 56 in English, John. I'm sorry.
Yeah.
I was wondering, it's like, what's 56? My yearly salary? Like in dollars? 56? Yeah. Okay. All right. Oh yeah, pesos. All right. So guys, we know we're going to multiply these out, but what are we going to do in between each of these? Like 1 man, 2 men, 3 men. What do we do there, guys?
Add them.
We add them, right? Because it's either 1 man or 2 men or 3 women. That means at least, okay? Donnie, does that make sense, like the difference between when to add and multiply, okay? I think you had the idea that you had to add at some point, but you forgot whether it was, if it was either disjunction or conjunction. So for disjunction, you have to add, okay? So, does that make sense, guys? We're going to add these up, okay? And then we're going to get some sort of value out of this, to which I'm not going to guess.
So whenever you have an OR, you have to add, and is multiply, right?
Right, and means multiply, or means to add. So it's either 1 man, or 2 men, or 3 men, to get at least 1 man. Okay? Was someone able to figure out the sum and product of this?
It would be, at the very end, it's 596.
596, thanks Greg. Anyone disagree with that, or everyone go with Greg? Okay. Well, actually Greg's response. You might not be okay with Greg, but at least his response. Okay. All good, guys? Any questions about this? Okay, so that's an at least problem. Okay, now let's take a look at a most problem. Okay, oh, I'm sorry, it's another at least, I'm sorry. So how many 7-person juries can be selected that consist of at least 1 woman? All right, there's 2 ways to do this problem. Both of them are correct. One of them is going to be painful, one of them is going to be a little bit easier to do. So, if you guys have at least 1 woman, what's one way to be able to figure that out?
Just
Okay, so we start with 1 woman, right? And how high do we go up to?
7.
7, right? So we have to have something for 1 woman, 2 women, 3 women, 4 women, 5 women, 6 women, and then surprise, 7 women. Let's do it this way because we want to. Yeah. That's painful, isn't it? I mean, it's not hard, it's just painful, right? Cutting the grass. We can do it whenever we want, we just don't like to. Let's just set up the first one for 1 woman, and then I'll set the rest of them up, okay? If I want to select 1 woman out of this jury, okay, I think we have, what, 9 women to start with, and we want 1 of them, correct? Which by default means what?
6 men.
We want 6 men by default. Does that make sense to everybody, guys? There's 8 men. To finish it out, we have to have the other 6 in there. Okay, so that's all good with everybody? From here, guys, isn't the trick just keep descending, ascending, descending, ascending? So you just keep changing all of them by 1 on the bottom numbers. So for the next one, instead of 9-1, that would be 9-2, right? And then instead of 8-6, that would be 8-5. For the third one, 9-3, 8-4, 9-4, 8-3, oh, 9-5, 8-4, oh, no, I'm sorry, 8-2. Thank you, sir. Sorry, I was going the other way. That's not good. 9-6, 8-1, and then mercifully 9-7, 8-0. All right.
Is there a way we can do this with n, or creating like a formula or something that kind of just expresses that in a condensed form?
I guess you could use a summation. and try to do an index and try to write it out that way.
Okay.
Or you just do this. Because, I mean, truly, we are going to sum this up. So, I mean, you could write a summation to do it shorthand if you wanted to, but it might be nastier to do that. So you might, by the time you're done writing a summation, you'll probably be done doing 3 of those. All right, so I guess now all we have to do is just do some calculator action and go ahead and figure out some numbers, right, guys?
What's the easier way?
What's that?
You said there's an easier way. What's the easier?
Oh yeah, there's an easier way,
Okay.
but I'm going to make you guys do the harder way first, because
Ah.
nobody suggested the easier way yet. So, all right, so let's just get some numbers out here. All right, 9, 1 is 9. Oh, 8, 6, 28, I believe. 9, 2, 36. 8, 5, 56, I believe. And you guys can check me on this, please. I'm not going to do 9, 3, because I don't know that one. And 8, 4, I'm not going to do that one. So some of these in the middle I'm not going to do, but I'll do some of the ones towards the end. 8, 2, I think we've done that one already. I think that's 21. Yeah, thanks. And then 9, 6, that's going to be 36 times 8. And then 9, 7, that's going to be 36 times 1. Okay, so if you guys can help me out with, there's 5 of them up there. So if you can randomly pick one of those 5, stick in your calculator, and let me know what you get.
For 3W, it would be 84
Okay.
times 7.
Times 70. Thanks, Frank. Okay, that's better than what I had. So, actually, I thought we had 8-3. Yeah, 8-3 was 56. So that's 56.
It's 126.
126 for 9-4. Okay. And then 9-5, anyone got that one? 126 as well? Okay, thanks. All right, now I do need to make sure that these are correct before we go on.
9-6 is 84.
9-6.
Yeah, but the 6 one.
Okay, gotcha. So this guy right here should be 84. Okay. All right. Any of the other ones that might be incorrect? Because of course, when we do it the other way, I want to make sure we get the same answer. So you guys at least believe me that there's another way to do it. All right. And then of course, guys, we're going to add all these up. So let's just go ahead and stick it in the calculator. When somebody gets a sum for this, actually a couple people get a sum, so that way we can all make sure we got the right answer, we didn't make any typos in it. If I had a calculator, I'd do it, sorry. 19440. 19440. All right, thank you, Mr. Weber. Now, just to verify, not saying he's lying to us, but
Unless I typed it wrong.
How can 94 and 95 both be
symmetric.
9-6 and 9-3 are also
Yeah.
both 84.
Yeah, the binomial distribution is symmetric, so if it's equidistant from an average value,
Got it.
so it's just like a normal distribution. So, except it's a binomial distribution, which actually approaches the normal distribution as the sample size becomes infinitely large, central limit theorem, regardless. But this is the statistics. Okay, so that's a hard way to do it. All right. Maybe there's an easy way to do it. I don't know, and maybe we got that right. So, all right, let's think of it another way. All right, couldn't we figure out the total number of 7-person juries and subtract what?
All main jury.
Yeah, just basically the all-man jury, right? Because basically, we could say that this jury, that's at least one man, basically is every possible 7-person jury except for the one that's all men. Okay, so if we knew the total juries, so we'll say or, we could say the total number of juries minus the juries of all men, okay? That's a faster way to do it. Not saying it's easier, okay? In fact, it'd probably be easier to do it the top way logically, okay? This way is probably going to give some of you guys fits, because you're like, well, how do I even figure out the total number of juries that can be picked? Or how do you set that up? Okay, so I'm just trying to give you guys 2 different ways to do it, so if you see this on an exam, at least you know one of 2 ways to do it. All right. What's the total number of ways that I can pick a 7-person jury? See, that's why it's not as easy.
It would be
17.7. How'd you get 17? I don't see a 7 up there, 17 anywhere.
I added the 8 minutes.
Yeah, 8 plus 9 is 17, right? There's a total of 17 people,
Oh,
of which
yeah.
we won 7. Isn't that the total number of ways that we can pick the jury? Okay, that makes sense to me. Nice, Greg. All right, what about all men? Well, yeah, it'd be 8-7, and by default, 9-0, right? All right. So that's the faster way of doing it, but again, you have to be smart enough to set it up like that, okay? So it seems like the first way is just more intuitive for you guys, just because you just beat it up and do it, the brute force of the bully method of doing it, okay? All right, so if somebody could be so kind into their calculator and do 17.7, I bet you it's going to be 19,448, because 8-7 is 8 and 9-1 or 9-0 is 1. But if somebody can verify that just to make sure we're good with that. That looks good? Okay. And 19,448 minus 8 is 19,440, which is what we got from before. All right. So, unfortunately, guys, if you have one of these at least problems, if you have a lot of them to do, it might be beneficial to try to think of it like the total minus maybe 1 or 2 of them, okay? That's called the complement of that, okay? But if you can't think of it like that, like if you're sitting there and you're like, I just can't do it, just bully it, okay? I mean, quite honestly, how long is that going to take you guys to do? Like 5 minutes at the most to check it twice, okay? So, I mean, it doesn't matter which way I do it, except if we start having, what, like 30-person juries, and then I say at least 1, then it better matter, right, guys? Okay. All right. So questions I can answer about these problems to where we have to select and we do some sort of counting methods with combinations. Okay. So let's go ahead and extend that, and let's extend that to probability as opposed to just going to be counting methods. Okay. Now we talked about probability a little bit last time. Remember, that's the number of desired divided by the total number of outcomes, right? So if we know the number, in other words, these guys right here, that's the number of desired, and then divided by a total number, it should be okay for this. Okay, so these aren't any more difficult than what we've been doing, except now we just have to divide by a total. All right. So a box contains 5 red and 7 green marbles. We're randomly selecting 4 from the box. Okay. Total number of ways, probability that we pick 3 green and 1 red. Probability we pick at most 2 red and then at least 3 green. So let's go ahead and try to knock that one out. The first part's the easy stuff, and then after that, maybe not so easy. So, all right. So how many total ways are there to select the marbles? Okay. So anybody have an idea as to perhaps how we can compute that?
There are 12 marbles, right?
Yeah, there's 12 marbles total, right? Of which we want 4. There you go. So just 12 choose 4, that's all it is. Okay. Does that make sense to everybody, guys? When I talk about total number of ways, you just add the total, and then you figure out how many you're selecting from there. Okay. And then if you guys would be so kind as to throw that into a calculator.
495.
One more time?
495.
495, thank you, I'm sorry. Okay. So, easy enough for that one, right, guys? Okay. For item B, okay, so now we're saying probability. So make sure when you guys are doing your homework and also when you guys are taking the exam, note the difference between probability and number of ways, okay? Because if you do the probability and I'm asking you for a number of ways, you haven't necessarily answered the question, okay? You've got the answer somewhere in there, but you haven't indicated it correctly, okay? So the probability that we pick 3 green and 1 red, okay? So basically, guys, we're going to have a fraction. All right. The total number of desired, okay, that's the numerator, okay? Well, guys, how do we pick 3 green and 1 red marble? Well, how many total marbles are there that are green? 7. How many of those do we want? Okay, and it's a combination, right, guys? How do we know it's a combination as opposed to a permutation?
It doesn't matter how or what
Yeah.
I pick them.
The marbles don't have names or anything like that, okay? I can't pick one marble and it doesn't look any different than the other one, right? They're indistinguishable objects, okay? I think we have 5 red marbles, right, guys?
Mhm.
Of which we want 1, okay? So wouldn't the numerator represent the number of possible ways that if there were 7 green and 5 red, that we could pick 3 of those to be green and 1 of them to be red? Number of desired in the numerator. What's the denominator? What's the total number of ways?
495.
Yeah, 495, right guys? It's almost like I made you compute that on purpose. Isn't the denominator going to be how many possible ways there are to pick the 4 marbles? Okay, so that would be 12, 4, which we already knew to be 495 from the previous example. Does that make sense to everybody, guys? Not meant to be difficult, it just is what it is, right? Okay, now, what's that?
You can like add them.
Oh, we're going to multiply these together, John. And that's just
But,
because...
like, 7 plus 5 is 12.
Oh, I see what you mean. Yeah, you could add these to be able to get to the total number. I see what you're saying. Right. So
12, 4 is the same as the that.
right. It's the same number as this guy right here from the previous.
Oh, no, but it's not the same as 7 over.
Oh no, it's absolutely not the same. No, it's completely different than that. Okay, I see what you're saying, sir. Okay. Yeah, it's different because of the subtraction in the formula for the combination. Okay, it's not all commutative for this one. It's associated. Okay. All right, guys. So we just go into our calculator. Did anyone figure out 7, 3?
Yeah, it's 35.
35. And that's 5, and the numerator for 5, 1, 495. So then this is just going to be 135 over 495. So if you guys could approximate that to 3 decimal places to get a probability. 0.3535. Okay. So 3, 5, 4. So it's not completely unlikely that that could happen, okay? It's not extremely likely, okay, but it's not like it would never ever happen to somebody, okay? So does that make sense, guys? When we're computing probability, total number of desired on top, and then in the denominator, it's just going to be how many total possible ways, okay? It's not too difficult. It's the same stuff we've been doing. We're just taking it one step further. Okay. All right, for item C.
Wait, is that percent? 35.
Oh, if I was to write that as a percent, John, that would be 35.4%, okay? Usually when we talk about mathematical statistics, we don't even like percentages, because quite honestly, guys, percents aren't even real numbers. They're just ways to represent a part per 100. So this would be like 1% out of maybe 495 or whatever. If we were to do a different number, that would be the expected value for that. Okay? Other questions, guys? Okay. So for item C, this one says, what's the probability that we will select at most 2 red marbles? Okay, so now we have an at most problem. All right. If I want at most, okay, that means I want at maximum 2. So at least means at minimum, at most means at maximum. So what's one possible outcome for at most 2 red marbles?
So
We could have 0 red marbles, right? So one could be 0 red. Okay. What's another possibility?
1 red,
1 red marble, right? What's another possibility?
2 red.
2 red marbles. Could we pick 3 if we want at most 2 reds? No, not possible, right? So when you see the words at most, you start at 0 and then you go up. If you see at least, you start at that number and then you just keep going up to the maximum. Okay, so does that make sense to everybody, guys? Okay, at most means you start at 0. At least means you start at whatever the given value is, and then you just keep going up to whatever the max is. Okay? All right, so now all we have to do is just set up these problems for 0 red. Okay, now remember, if you pick 0 red, by default, you have to pick some greens. Okay, so you're still going to have 2 combinations. All of these problems are going to have them. Okay, sorry. There we go, that's better. All right. So if I want 0 red marbles, okay, what's the combinations set up for both of those? So for the red ones, what would that be? 5 choose 0, okay, and then 7 choose 4. Nice. Does that make sense to everybody, guys? We're picking 4 marbles. We're picking 0 red, so by default, there has to be 4 greens. Okay? There's no other way to pick 4 marbles unless you pick 4 of one and none of the other. Okay? For 1 red, that would be 5,
One.
1. And instead of 7, 4, it would be 7, 3, right guys? Okay. And then once you see that, then the rest of it's easy, right? You just keep going up on the reds, down on the greens. So it'll be 5, 2, 7. Okay. And then just like before,
No, no,
no,
7.
7, 2. I'm sorry. I went the other way. Sorry. Here we go. All right. So that look good, guys? Any questions about that? Okay. And then what's the denominator going to be for this? Is it still 495 or do we change it?
The same 495.
It's the same, right? I haven't changed the number of reds and greens. I haven't changed that I'm choosing 4 marbles. So it's still going to be 12, 4, which we already know to be 495. Okay? Now, as soon as I change and say that we're picking 5 marbles, or if I say now I'm changing it to 4 red and 8 green, then you got to change the whole thing. Okay, so make sure that if you understand that any of the parameters initially change, the whole thing changes. Okay? Good.
We only have to use the probability. We only have to use the denominator on a probability.
Correct. If it does not say probability, you just worry about the numerator. Okay, good question, Dave. Okay. Other questions, guys, I can
Now,
answer?
4 red and 8 green, it will be the same as the denominator because there are 12 marbles and you're choosing 4, right? If you said, if I'm choosing 4 reds and 8 green, on the denominator it will be
Yeah,
12.
it would still be the same for
Yeah.
that. But if I change like anything else, like if I
Yeah.
increase the number
Yeah,
that I'm
then.
picking or decrease. Okay, so let's just go through and pick this out or compute this. 5, 0 is 1. 7, 4 should be 35, shouldn't it, guys? Okay. 5, 1 is 5. 7, 3 is 35. 5, 2 is 10. 7, 2 is 21, I believe.
Yes.
Yes.
Okay. And then we know what the denominator is, 495. 420 over 495. Okay. And then, that's a pretty high probability.
0.849. 848. Well, no, yeah, it's 848.
Is it 848? Okay.
Because it's 8484.
If you were off by 1,000th, I wouldn't slay you guys. Especially since we're doing fictitious problems where we're just picking marbles out of a box. Now, if you were engineering a car and somebody's life was in jeopardy of that, then I might be a little more upset, but no.
Your number wouldn't stop there.
Yeah, that's true. You're exactly right. The level of precision would not stop at just 3 decimal places, hopefully. Okay. All right, guys, any questions about this one, guys? Okay, same exact stuff we did before, except now all we're doing is we're just throwing in the total number of ways and dividing by it. Okay. Last one, letter D. What is the probability that we will select at least 3 green marbles? Okay, so this is an at least problem. So again, guys, one of the things you want to make sure of is that you read the condition. Okay, at most, at least. At least, remember, means you start with that number, and then you just keep going up till you hit the max.
Either way, you have 2 things to set up for this.
Yeah, so for this one, at least 3 green. So we start with 3, right, guys? So there will be 3 green, okay? And there will be 4 green. Would there be 5 green? No, you can't pick 4 greens, right? Because there's only 4 marbles that we're picking from. It's not possible to pick 5 marbles or 5 green marbles if you're only given 4 to start with. Okay? For 3 green, 7, 3, 5, 1. For 4 green, 7, 4, 5, 0. We still divide that by 12, 4. We're not changing any of the initial conditions, so we're stuck with what we have there. Okay? The good news is, guys, don't we already know all those combinations from the previous problems? Okay? So we can just borrow and not use our calculators again. In fact, when you guys are doing your homework problems and on the tests, just go back and borrow again. Okay? Don't necessarily think you have to compute everything, because a lot of times you're already going to have these computed. Okay? So we said that 7, 3, that was going to be 35, I think, was it? Yeah, 35. And 5, 1 is 5. 7, 4 should also be 35. And 5, 0 should be 1. 12, 4 we know to be 495. So that's going to be 135 plus 35 is 170 over 495. Is that correct, guys? No?
No, it would be 210.
210. So where did I get that from? Oh, I see what I did. I said 135.
Yeah, rather than 170.
Right, I didn't carry enough. Okay, so it's 210. Gotcha. Okay. And then somebody can go ahead and compute that, please. 424. Okay, sounds good. So approximately 0.4. All right. So let me give you guys a minute to make sure all of this is okay.
These give a lot of irrational.
Well, it's still rational, okay? Because anytime
Well,
you,
that's true, it is rational.
yeah, it's all rational. There's just not as much repetition as you'd like to see, okay? And that's just because it's still an integer over an integer. It's just not in the most simple form. Okay.
It's a lot more than.
Yeah. All right, guys. Questions I can answer before we move on. Okay, everybody feel okay about these? Okay, John, go ahead, sir.
Yeah, I'm not. I got something different. Like what? Like the last one you had the 5 zeros.
Right.
So what I did, I started 7054.
Mm-hmm. Now that's because this one was an at least problem. The last one was at most, okay? So remember, you have to look at the condition. So at least means you started that number, right? And then you work your way up. At most is where you start at 0, okay? So I think you might have just read that as at most rather than at least, okay? Does that make sense, John? Okay, that was just an accidental read, I think.
Oh yeah, okay, that makes sense.
Okay, good. All right. Other questions, guys, I can answer before we move on? Okay. So the last set of questions here, these are a little bit different than the other ones, okay? So we actually looked at some of these types of problems last time, okay, where we had like the fictitious words and we rearranged the letters. But these are a little bit different than what we saw before, okay? So before we even do any of the problems, let's try to think about what we did on Wednesday last week and how these differ. So just scroll back a little bit to, well, for me it's scroll, for you guys it's flip.
Ownership.
But the first problem we did involving combinations and permutations, we looked at the word ownership, okay? And I think we just used a bunch of permutations, or we used like the spacing method, right guys, where we just were able to utilize factorials sometimes, all right? Now, I want you guys to flip back to the words that we're looking at now, like treetop, millimicron, success, okay? How are these words different than the word ownership that we looked at initially? There's some repetition, right guys? In other words, there's some indistinguishable L's, okay? There's some indistinguishable T's. There's some indistinguishable S's, right? So these are words that have some repetition in the letters, okay? So I want you to notice, guys, as soon as you see repetition, okay, these are all going to use combinations, okay? Because whichever T you pick, it doesn't matter which T you pick, right? They're indistinguishable from one another. It doesn't matter which E you pick. They're indistinguishable from one another, okay? So I don't want you guys getting confused as to when to use a combination, when to use a permutation. Okay? So everybody understands that, guys? Any questions before we move on? Okay. So let's kind of dissect the word treetop. Okay? So there's 2 T's in this word. There are 2 E's in this word. And then there's a R-O-P, right? All right, here's the way that we're going to set this up if there's repetitions in the letters, okay? If there's repetition, we know that there's a total of 7 letters in this word, right? Let's just say for some reason, the first letter that we're picking, or we're trying to decide what to do with, is the T's, okay? Guys, if there's 7 letters, and we only want 2 T's, wouldn't the combination be 7, 2, right?
Mm-hmm.
Now just go along with me, because you're thinking, well, what if I pick the E first? What if I pick the P first, okay? Wouldn't that change everything? No, it wouldn't, okay? So if you give me a chance to explain, so just follow along with me. So now I've gotten rid of the T's, right? I've selected those 2 T's. There are 7 spaces, and I have 2 T's to pick from, right? Okay. Let's say I want to pick the e's next. What's the combination that would follow suit for the e's?
Same, 7, 2.
Not
No, 5,
7,
2, 5, 2.
5, 2, right guys? Because haven't we picked the two t's?
Mhm.
They're gone. So now there are 5 spaces of which we want to fill them in with 2 e's. Okay? Now the 2 e's are gone. Okay, so no more e's. For the rest of this, there are what? 3 letters left, or 3 spaces left. We want 1 for the R. There are 2 spaces left after we select the R. We want 1 for the O. There is 1 space left, and there's 1 for the P. Okay, so this is one of several different setups that we could pick for this. Okay, so go ahead and copy that down. Okay, and then I'm going to explain why it works. Okay. But everybody understands if I was to ask you to set it up, how that works. Okay, you just basically get a count, and then you just keep subtracting out once the spaces are filled in. Okay, so this is still sort of the space method, except we're not drawing out the spaces. All right, so I asked you guys, okay, how come it doesn't matter that I selected the T's first? What if I pick the R's first, or the P's first? Why does it not matter?
Does it still take off the same amount of space?
I'm still taking off the same amount of spaces. And guys, what am I really doing with all of those different numbers? Multiplying. Correct me if I'm wrong, multiplication is commutative and associative, right guys?
Mhm.
And the formula, by the way, for a combination, correct me if I'm wrong, you don't have to copy this down because we already have it, is n factorial, r factorial, n minus r factorial. It's all multiplication. So when it comes down to it, guys, it doesn't matter because you're still going to be subtracting out the number of spaces, which is the r each, or how many we're picking, n is the number of spaces available. So you're still going to get the same number no matter what. Okay? Does that make sense, guys, as to why it doesn't matter how you set it up? If you don't believe me, just go home and do all of, I think there's going to be maybe 8 or 9 possible arrangements that you can make with this. Do all 8 or 9 and believe me if you get the same answer. Okay? All right, now our job is just to do some basic computations. We're done with this problem. Okay? 7-1, I believe, is 21. 5-2, I believe, is 10. 3-1 is 3. 2-1 is 2. 1-1 is 1. So 6 times 21 is 126. 126 times 10, 1260 maybe? So I can verify that just to make sure I didn't make any computational errors. Which is the bane of my existence because I want to get done. Okay. Yeah. I want to get done that stupid stuff with the computation. I'm always interested in doing the setups. Okay. Does that make sense, guys? Any questions? They're not difficult, right? It's basically the space method. Just write them out and just cross it out as you go along. By the way, another way you guys could have done this, okay, and this will work every time as well, you could set it up as 7-2, 5-2, and then since all the other letters are distinguishable, you could have done 3 factorial, okay? Because it doesn't matter, since there's 3 different letters, 3 times 2 times 1. In fact, that's what 3, 1, 2, 1, and 1, 1 works out to be. So that's another way to do it, especially if you have a lot of distinguishable letters or unique letters. Okay, that might work a little bit faster for some of you guys. If you don't like that, just do it the first way. Okay, it's a brute force method. Okay, all good, guys? Okay, let's try a few more of these. Okay, same idea, except this time now we have the word millimicron. Right, it's going to be the same thing. We just have to pick out the number of letters of each type and then just set it up using our combinations. Okay, so for the M, I think there's 2, right, guys? And then for I, we have 4. Is it 3? Okay, thanks. I can't count. And then 2 for the L's. And then a CRON. Yeah, for each of those, I think we have 1 of each of those. So the milli is all the repetition, and the cron is the one that's unique. So now we just figure out a total number of the items that we're looking at. Okay. So that's going to be 4, 8, 11, I believe, is the total. and then just like we did in the previous problem, we're just going to go ahead, set it up, and then just multiply it out. Okay, so if I wanted to, and I just go right down the list whenever I do these. I just pick the M's first, and then the I's, and then the L's, and the CRON. It doesn't matter whatever order you want to pick them in. It'll still give you the same answer, as long as you do your computations correct. So if I wanted to pick the M's first, okay, what would be the combinations for this instance in selecting M's?
11, 2.
11, 2, right? There's 11 possible letters. We want those two M's. If I want the I's,
9.
that would be 9 and then 3, right? Okay. And guys, remember, it's 9 because we picked those two M's. Those are done. You can't repick them once they're put in their places. Okay. Now we're done with the I's. Okay. So now we're on to the L's. So for the L's, what's that combination going to look like? 6, 2. Nice. We've gotten rid of 3 more letters. So that 9 minus 3 is 6. And then we want 2 of the L's. Okay? And then we could do 4, 1, 3, 1, 2, 1, 1, 1. Or, what's a little bit easier
4
way?
factorial.
Just 4 factorial, right guys? So I'm going to suggest, since there's 4 unique letters, that we just write that as 4 factorial for the CRON, okay? Because there's 24 different ways that we could arrange those. Okay, so we'll just say 4 factorial. Okay, is that good with everybody, guys? Any questions? Now it's just monkey punching the button, right? Okay, the rest of it's easy. Okay. 11, 2 should be 55. 6, 2 should be 15. 9, 3,
84.
84. That's right, we did that one. Why don't I remember that? And then 4 factorial is 24. All right, and then we just multiply those together, and we get some ungodly, useless number out of that. So somebody figured that out, and they'd be willing to share.
1,663,200.
Gotcha. 1663200. Look good to everybody, guys? Okay, nice. Okay. Guys, all we're doing here is basic arithmetic, right? We're setting up the problem, and we're letting the calculator do everything else. Okay, Johnny?
You also do 11, 3, and 8, 2.
Mm-hmm.
So you could like switch.
Oh yeah, sure, it doesn't matter, because remember, it's all multiplication, commutative, and associative, okay? And whichever way you want to do it, that's fine, okay? My suggestion, though, is leave the unique letters for the end, so that way you don't have to worry about making more combinations than necessary, okay? Other questions, guys? Okay, so the next one is basically the same problem, except this time, we're now limiting what the positions for this, okay? So, for letter C, it's still the same word, millimicron, except the first letter must be an M. So we still have an M, we still have I's, we still have L's, and then we have CRON. Okay. Now, we started out with 2, right? But aren't we saying that the first letter must be an M? So basically what we're saying is that I've affixed the position of one of those M's. It's gone. Okay? I've basically taken it out of the theoretical bag of letters, and I have to put it in that first position. Everything else is going to stay the same. So that might be an easy way for you guys to be able to work with the problems where you're selecting one of them to start with. Okay? So just get rid of it initially, and then approach the problem in the exact same way. Does that make sense, guys? You're just basically crossing it out, and then you go ahead and just set it up as such. Okay? All right, so would we want to start with the M's this time, guys? No. Let's start with the I's and the L's, and then we could just do a 5 factorial, right? That's way easier than trying to do more combinations. So, if I was to pick the I's, what's the combination that would represent I's? 10, 3, right? Not 11, 3, right? We have to use 10 because we've already selected one of the N's. So it would be 10 combination 3. Is that good with everybody, guys, as to why it's not 11? Okay. For the next one, which would be the L's, what would be the setup for the L's for the combination?
7, 2.
7, 2. We picked 3 of the I's. They're gone. So now we have 7 letters. Of those we want 2. All right? The rest of them are all distinguishable. They're all unique elements. So couldn't we just do 5 times 4 times 3 times 2 times 1, or in other words, 5 factorial? and that's for the MCRON.
Oh,
And
the first one is M, that's one, okay. got it.
Correct, right, because it's only one, okay? Anytime you have a unique, just stick that in with the factorials. That makes it really easy. Okay, questions? Just stretching. Nope, you're fine. Okay. At this point, guys, let's just go ahead, compute it out, and we'll be done with this. Okay, we already know 7 2 is 21. The 5 factorial is 120. I don't know 10 3 off the top of my head.
120.
120 as well. Well, that's funny. Not really. It's I guess unprobabilistic would be a better word for that. So 120 squared times 21.
300.
30240. All right. Guys, any questions about this? Okay, same thing as we did before, except now we're just exhausting a couple of the decisions before we go through and finish. Okay. All right, guys. So for the last one we have here, now we're actually just picking maybe, or same sort of thing, except that we're just changing the word. So hopefully this isn't too difficult. So we have the word success. First letter must be a U. So we're going to do the exact same thing as we did before. We're going to list out the unique elements. Okay, so we have 3 S's, we have 1 U, and then we have 2 C's and an E, right? And it says that the first letter must be a U, right? So we just cross out the U. Okay, so let's get rid of that U. And then at this point, guys, we just set up the combinations just like we normally would, okay? So I think the way we might set this up, and correct me if I'm wrong, we have 6 letters. Of those, we want 3 for the S's. And then we have 3 letters. We want 2 for the C's. And then we have 1 letter, of which we're going to get 1, or we could do 1 factorial if we really wanted to, although that doesn't really help us. Does that setup look okay to everybody, guys? Any questions about that? Okay. Now our job is just to do the computations and then be done with this problem. Okay, so 3 2 is 3, 1 1 is 1, and then 6 3. Anyone got that one?
20.
20. Okay. So we get 60 out of this. Not necessarily all that exciting, but not too difficult. Okay. Better than a mathematically proved by function. All right, guys? Okay. All right, questions I can answer, guys, about being able to do these counting methods? Okay, hopefully not too difficult. Jump on, sir.
For C, do you just ignore the M that's at the beginning?
Correct, right. The reason we do that is because we just took it out and it's already been placed into its own spot. Okay, so that M has no more bearing on the problem whatsoever.
Yeah, so it's as if you like took it out and it would be the same.
Right, and then what that means is instead of working with 11 letters, now you're working with 10 letters.
Yeah.
Okay, so it just basically creates a new word, if you would, or a new number of letters you're selecting from. Okay. Other questions, guys? Okay, so we're all done with the counting method stuff. We're still going to work with combinations and permutations, but this time we're actually going to be proving some stuff with those. Okay, so, and I know how much you guys like proofs. It's the only thing that makes this class fun, right? Yeah, sure. So I'll wait till everyone gets copies of these.
Yeah. First one we whenever I decide if I can balance that procedure
What's up?
You can get more copies?
Oh, I didn't give you guys enough? I was doing it.
Oh, thank you.
You're welcome, man. Okay, sorry about that, guys. Okay, anybody else need a copy or everybody got one? Okay, so essentially, we've been working with the idea of applying the definitions of permutations and combinations. Now we're going to prove some of these, okay? So essentially what we're going to do is if I give you a property, you're going to prove it, okay? And we just have to remember the definition of permutation, the definition of combination. So let's write that out just to make sure we remember, okay? So we have a permutation, okay? Permutation n comma r is equal to n factorial divided by n minus r factorial. Okay, so that's our definition. And essentially what we're going to be doing is we're going to be substituting the values back into there and then just proving. Okay, so most of these guys are just algebra problems. Okay, now we are going to have some factorials with common denominators, so that might get a little bit dicey for some of you guys. So what we're probably going to do this afternoon is we're probably going to prove the first two of these. Sorry about that, I didn't mean to roll away. We'll probably prove the first two of these, and then next time we'll prove the rest of them. Okay. So I give you guys a problem to where for all integers n, for where n is bigger than or equal to 2, regardless of what the number is, the permutation n plus 1 comma 3 is equal to n cubed minus n. Okay. So let's go ahead and prove that. We start with n plus 1 representing the n, and then 3 representing the r. So wherever I see an n, I'm going to plug in n plus 1. Wherever I see an r, I'm going to plug in 3. So basically we start by doing substitution. Okay? So permutation n plus 1 comma 3 is going to be equal to n plus 1 fact. Okay? So all I'm doing is wherever I see an n, I'm plugging in n plus 1, divided by n plus 1 minus 3 fact. So let me make sure that's okay with everybody. Okay? All I did there was I just substituted n plus 1 for n, 3 for r. Is that okay with everybody, guys? Just using the definition of permutation. Okay? If I was to ask you guys to prove this, I don't think there's anybody in here that wouldn't just subtract 1 and 3, right? You would just combine that in the parentheses. So this would wind up being n plus 1 fact divided by n minus 2 quantity fact, right? Okay. That's easy. I mean, nobody in here can get that wrong. Now, we need to prove that it's equal to n cubed minus n. Okay, so does anyone maybe have a suggestion as to perhaps how to simplify this? Or
Do n plus 1 multiplied by n, then n minus 1, then n minus 2, then n minus 2, and you, what you say, cancel them out.
Yeah, this is stuff that we did on the last examination where you simplify factorial expressions. Basically extend the definition of the factorial. So let's do that. Okay? So n plus 1 factorial is equal to n plus 1 times n minus 1 times n minus 2 all the way down to 1, right guys? That's the definition of n plus 1 factorial. Okay. And that's still divided by n minus 2 fact. But n minus 2 fact, if I was to expand that, would be n minus 2, n minus 3, all the way down to 3, 2, 1. Okay, so all we did there, guys, was we just utilized the definition of factorial. And remember, factorial means you just multiply in descending order. Okay, is that okay, guys? Any questions about what we did there? Okay. Or would you say to do it at this point?
N minus 2 and n minus 3 can cancel them out.
Yeah. Any factor, n minus 2 or lower, is going to cancel out. And I think now everybody can see that this is going to really nicely work into n cubed minus n. I'll still show you guys how it works out to be that, okay? But I'm betting most of you guys are like, oh, okay, now I can see that there's going to be a cubic term in there by the multiplication, okay? So let's go ahead and finish this, okay? I'm going to take the n and I'm going to distribute it. Remember, guys, when you have a singular monomial and you want to distribute it, you don't...
Actually, that's a perfect square. N squared minus 1.
We can do that and get the n squared minus 1 out of that. Or we could just distribute. It doesn't really matter, right? But yeah, you're right. Okay. So this would become n squared plus n, and then n minus 1. Now we just FOIL it out, okay, and then eventually we can combine some like terms. So after FOIL, we get n cubed, and then we get minus n squared, plus n squared, minus n. Okay, just by doing a first outer inner last on that. And then I think it's pretty obvious that the inner terms of n squared are going to cancel each other out. So I think we wind up with n cubed minus n. So guys, essentially all I'm asking you guys to do is to use the definition of the factorial to be able to simplify and to work with what we have for our for these permutations. Okay? Does that make sense to everybody, guys?
Then what is the reason of giving n is greater than 2?
Well, because if it's nr, think of, if I asked you to pick 5 elements from 3,
Okay.
you can't do that. So this first number has to be at least as big as the second number. And the only way to guarantee that is to make n 2 or better. Okay? So otherwise you can't, it's just outside the domain of a permutation. Does that make sense, Art? It really has no bearing on the algebra of it. It's just making sure that the domain's specified for the problem. It's like when you're doing an integral and you get like the ln, if you forget the absolute values, technically it's wrong, but your teacher might not mark you wrong sort of thing because it's domain-based. Alright, other questions, guys? Okay. So that one wasn't too bad, okay? Now, unfortunately, the second one's a lot uglier, okay? So let's go ahead and tackle that one. So this one says that, again, for all n bigger than or equal to 2, permutation n plus 1, comma 2, minus permutation n, comma 2 is equal to 2 permutations n1. Okay, so what we want to do with this, guys, is work with the more complex side. You don't want to work with the easier side, try to make it look like the harder. There's just no way. Well, there is. You have to do partial fraction decomposition. And you don't want to deal with that if you don't have to. Okay, so let's go ahead and just try to simplify the left-hand side. Okay, so I have permutation. I'm just rewriting this. You guys don't have to do this again. I'm just rewriting it for my own benefit. Minus Pn, comma 2. We're going to use the definition of permutation. So this is n plus 1 fact divided by n plus 1 minus 2 fact minus n fact divided by n minus 2 fact. Okay, and that's for this fraction right here. So, let everyone get a look at that and make sure everything's okay. So, any questions about how we set that up, guys, before we go on? Okay, everybody feels good about substituting and being able to work with the substitution for a permutation. Okay. I can't imagine that anybody wouldn't know what to do next with this, because in the first fraction's denominator, there's an n plus 1 minus 2, which just happens to be the exact same expression that we ended up with last time, I think, except instead of n minus 2, it's n minus 1. So now we're going to get n plus 1 fact divided by n minus 1 fact minus n fact divided by n minus 2 fact. Okay. Now, what I see a lot of students try to do is I see a lot of students try to cancel out terms because they're like, oh, okay, I can expand n plus 1 and I can expand n minus 1 factorial. But what happens if you expand and cancel? What are you never going to get to on the right-hand side? You'll never get to 2 permutations of anything. You'll get to a polynomial, but you won't get to a permutation, okay? So, because it's being equal to a permutation and not a polynomial, we can't use the canceling stuff, okay? So does that make sense, guys, as to why we can't cancel, okay? All right. So the question is, what do we do? Well, we need to somehow make this into a singular fraction, I think, okay? If we can get a single, go ahead, we need a common denominator, right? Guys, if we get a common denominator, then at least we might have a punching chance of getting the 2 permutation n1, okay? So the question is, though, what is the common denominator between n minus 1 fact and n minus 2 facts.
So
So,
multiply both of them.
no, you don't want to do that. You're going to be, that would make this problem so ridiculously difficult, nobody would want to do it. Okay? It's actually n minus 1 factorial. Okay, let me illustrate why. Okay, I'm going to do this off to the side. You guys don't have to write this. Okay. N minus 1 factorial is what? N minus 1, n minus 2, n minus 3, da 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 da, 3, 2, 1, right guys? N minus 2 factorial, which is the other denominator, is going to be n minus 2, n minus 3, all the way down to 3, 2, 1. Okay? Guys, both of those expressions share every single factor
Except n minus 1.
except for n minus 1, right guys? So if I was to just simply do, what could I do to make n minus 2 fact look like n minus 1 fact? Yeah, multiply both sides of that equation by n minus 1, right? If I multiply right here by n minus 1 on both sides, this would make it look exactly like n minus 1, okay? Art, do you understand that if you multiply those together, you would get n minus 2 squared, n minus 3 squared, n minus 4 squared. And then you'd have to multiply all the numerators by all those missing factors, okay? There's just no way we could do that, okay? It would just be too ugly, okay? So, and I wasn't trying to pick on you. It's not a bad idea. If you're ever confused with fractions, you usually just multiply them together and brute force it. This one, though, it would be so brutal that you couldn't overcome it. Okay, so now what we're going to do is by least common denominator, we are going to rewrite these. Okay, so we're going to have an n minus 1 fact, and we're going to have an n minus 1 fact. Okay, so all we're doing here is we're just getting a least common denominator. Okay, in fact, let's make a note of that. That the LCD, I'll get out of your guys' way, I know, is n minus 1 factorial. And if you don't believe me, look in the upper right-hand corner and you can see that all the factors are common except for n minus 1. It's the only one that we don't have. Alright, now, just like any fraction, you have to play that game of whatever's missing on top, you have to multiply to maintain equivalence of the fraction. Okay? To go from n minus 1 fact to n minus 1 fact in the first fraction. What do we multiply the numerator by, if anything?
Okay.
Nothing, right? It stayed the same. So the first numerator is going to stay n plus 1 fact. However, the second fraction, what do we have to multiply n minus 2 fact by to get to n minus 1
n
fact?
minus 1.
N minus 1, right? Guys, can't we see right here that we are missing n minus 1? So, if that's what we're missing, that's what we have to multiply the numerator by to maintain equivalence. Okay, does that make sense to everybody, guys? It's just like any other fraction. Whatever you're missing to go from one fraction to the next, that's what you multiply by. So we're going to have n fact, n minus 1. All right. So, everybody good, guys? Any questions thus far? Okay. That's a technique, by the way, that you guys are going to have to use quite often. Okay. When we start doing stuff with the binomial theorem, we're going to see this again. Okay. So, we'll see this a couple more times, but it's definitely something that you guys are going to have to utilize as we go along with the course. Okay. So, let's continue. Okay. I'm going to go over here. So let's just merge this into one fraction, I think. I mean, that couldn't hurt. I mean, that's why we got a common denominator. So we get what? N plus 1 fact minus, what do we have? N minus, or N fact N minus 1, all divided by N minus 1 fact. Okay. So we need to keep the eyes on the prize, right? Because we're trying to get to 2 permutations of n comma 1. Alright, so at least we've got a punching chance though, because we have a singular fraction. Okay, and at least we can do that. So, any suggestions as to perhaps maybe how to simplify any of this stuff?
Can do
John,
n factorial.
instead of maybe rewrite n plus 1 factorial, so John, how would you rewrite n plus 1 factorial, sir?
N plus 1 times n times n minus 1.
Or, sir, do you mind if I just write it like that?
Yeah, I guess, yeah.
Okay, so n plus 1 factorial, all I'm doing here is I'm splitting off the highest factor of that, okay? And I'll explain why I do that in a second. But does that make sense, guys, that everybody understands that these two things are exactly the same thing? I'm just splitting off the highest factor of n plus 1. It'd be like if I had, and you guys don't have to write this down, if I had 16 factorial, wouldn't that be 16 times 15 factorial? If I had 255 factorial, that would be 255 times 254 factorial. All I'm doing is I'm splitting off the highest factor. That's all I'm doing with this. Okay? Does that make sense to everybody, guys? Completely legal. I'm not trying to pull any hocus pocus. Minus n fact, n minus 1 fact, or n minus 1, sorry, divided by n minus 1 fact. Okay. Now, John, why in the world would you just want to split off one of those? Why didn't you split off like n plus 1, n minus 1, n minus 2? Why just n factorial?
You want to take the n common.
Yeah. Guys, isn't there a common factor of n factorial right here? Let's factor that n factorial out, and I bet you that's going to get us really close to what we need. Okay, so basically what we did was we just reduced the order of the factors, so that way what we could do is just factor out something that's common. Okay, so if I factor out an n factorial, inside of the brackets, I'm now left with n plus 1 quantity minus quantity n minus 1. So we just factored out a GCF of n. I want you to notice that I kept the parentheses there. Okay, I didn't mess around with those because I know we need them. Okay, because it's a binomial factor. All right. What's the next thing that we could do that's almost obvious?
N, then n minus 1 factorial.
Yeah. Guys, just combine like terms. Okay, distribute the negative, right? And then combine. Guys, if I combine everything in here, what does that work out to be inside the
N squared
brackets?
minus 1.
2. Just 2, right guys? So these n's go away because they're
Oh, okay,
opposites.
combine, okay.
And then minus 1 is just going to become a plus 1, right guys? So that just becomes 2. So we would get 2n factorial divided by n minus 1 factorial. Okay. Does that make sense, guys? Just some really basic Algebra 1 combined like term stuff. Okay. What do we do next?
N, you split it n into n plus minus
Yeah.
1.
Yeah, but it's just 2p and...
Yeah, it's done. I mean, isn't that the definition of 2 permutations of n comma 1? Okay, that's exactly what we needed. Guys, if you look at it, you have your 2. You could factor it off if you wanted to, but n is n, r is 1. So you guys are done with it. That's the very definition of 2 permutations of n comma n minus 1. Okay? So, like I said, guys, this one was obviously much more difficult than the first one because of the common denominator. Okay? All right, any questions I can answer for you guys? Go ahead, John.
Yeah, how is that permutation and number 1 work out?
How did I
We're trying to, well, actually I know how you got there, I'm just wondering why that's the, yes, that proves.
So, to go, are you asking like, why did we go from this step to this step?
I'm just, because you're trying to prove that it's equal to 2.
Right, so, John, if I had this, if I have 2p n comma 1, right? This guy right here, if I was to use the definition of permutation, that would be n factorial, right? Divided by n minus 1 factorial, right? Which is exactly what we have over there. So this is just the condensed version, or a different way of writing this exact same thing, okay? So all we're trying to do is we're trying to get to one fraction, and that's why we need the common denominator. And then once we get there, then we can just do our algebra to be able to get to this thing. Okay? Does that make sense as to how to see like what we're trying to get to?
Yeah, I just don't know why that on the bottom is
Is the common denominator, or?
I mean, that's the final step, right?
Oh, right here? No, we went over there. There's 4 more steps over there that we were working with.
Oh, okay.
Yeah, this is like step number 3 or 4, and then there's the 4 more steps over there to do the algebra to simplify. Okay? All right, other questions, guys? Okay, so don't forget, guys, I think next time assignment or not next time, on Monday, right, assignment number 9 is due, right, guys? Okay, so make sure you guys get a jump on that. You can do everything that's on assignment number 9. If you want to start assignment 10, you can do the first few problems on that as well.
Assignment 10 boss.
What's that?
Assignment 10 or is it a little bit?
No, assignment 10 is going to be the one due not next Monday, but the following.
Oh, that's
The last assignment.